Bismillahirrahmanirrahim. It's the part two from this video because the electric is turned off. Let me keep going. At last, I was talking about the equation number one, t, the time period equal 2 pi L divided on acceleration inside this root. To disappear this root, we will say the square from these two sides of this equation to be time square period equal 4 pi square multiple length of the pendulum divided on the acceleration. Here it's important. I'm talking about the inside the rate pen 4 pi square divided on acceleration. It's equal the slope. Here the relation between the acceleration with the slope is important, and it gives a meaning about why we are or why we will plot the slope and calculate it, because the slope equals 4 pi square divided on the acceleration, and we need to calculate the acceleration, and at the same time I can calculate the slope from the curve. That's mean I have equation with just unknown element. I can calculate it. I'm talking about the acceleration. By that, acceleration will equal 4 pi square divided on the slope. Slope, by taking any 2 points from x and y from t square period and length of the pendulum, I can calculate it, and actually I calculated it. It's equal 0.04. By that, when using equation number 4, I will have acceleration equal 985.96, but centimeter instead of meter divided on second square. Why? Because here I was working on centimeters, not meter. 20, 40, 60, 80 to 100 centimeters. I didn't write .2, .4, .8. Okay, by that, I have centimeters divided on second square. To convert it to be meter at second square, that will be equal 859 meter divided on second square. It's near from the right result, from 9.82 meter divided on second square. That's mean my result is acceptable. And this unit, it came from these two sides, from L and the time period square. The second square from the time period square, and meter or centimeter, it's coming from L, the length of the pendulum. Now, let's talk about the conclusion. As we expected, the relation between t square time period with second square at y-axis and L, length of the pendulum at x-axis, is linear relation, done with kind direct. That means by increasing one of them, the other will increase too. Your homework is important. That will give you opportunity to have enough experience to can pass the exam, and with some knowledge, prove the acceleration of free fall ball is equal 9.82 meter divided on second square. That's mean your result must be with meter divided on second square, specifically not with centi, because I said prove it, and your result must be near from this result, little bit up or down. That's mean I need near result. You can accept it, okay? By using simple pendulum according to the table below, 220 oscillations. Here, be careful. The situation is different with 20 oscillations, and discuss short results. This, the columns and the results. You need to solve it because I want to see this solution in your notebook at next week. Thank you about your listening and watching. Have a good day and see you at next lecture.